Today we're going to be building something similar to the first electric motor, first demonstrated by Michael Faraday in 1821. It uses some very simple tools to make a screw go round and round really fast. It uses an electric current to cause a force perpendicular to a magnetic field, making the screw turn.
To build this, you need a normal D battery, some wire. You can solder the top, but we broke it, so I'm gonna hurt myself. A magnet.
Why are you hurting yourself?
Well, it's gonna get hot.
Current.
The current
Right.
going through it heats up.
It's gonna go through you now.
Yes.
Sucker.
It's gonna be fun. And then different varying lengths of metal objects, which will conduct electricity.
So voltage 1.5?
1.5, yes. And the current is around 150. All right, now for a demonstration. If I can hold this correctly. My bad.
Yeah, just try to get it steady.
Yep. Okay. Take the magnet, place it on the screw, try and get it centered. Side of the magnet. I'm gonna say Tim broke it. Oh, there we go. Okay, here we go.
Yeah, keep it on. So I don't know if you guys can see. We got the there. We got. If it's not completely
Hold it.
centered correctly, balance, it'll go off that middle part. But once you get that speed going, it gets more and more steady. Tim, your finger, how is it?
Fine.
Okay, good.
I can smell smoke.
I can see the wire charring.
All right.
Very nice.
Very nice.
All right.
Good demonstration.
So Kyle, what happened?
Well, you see,
You don't know? I'll explain it. Okay, good transition.
we're going.
All right, so what's happening here? What we have, like we talked about, is our power source, and really all we have is power source and a magnet. And it just happens so that we have this rod that is able to freely turn. And this actual, should probably get that there. This phenomenon we're experiencing here has actually got a name. It's called Lorentz law. And you have the current going perpendicular to that magnetic field. The magnetic field's going up, down, north, south. It's going perpendicular to this magnet. So the magnet's force is then creating a centripetal force on this screw. And we get the spinning, the rotations. Some people that have done this before have said they've gotten speeds around 10,000 RPM. We do not have a tachometer, so we cannot actually gauge that. But we got it going pretty good in some earlier tests. We're going to show you some more tests. One of the things, though, that does hamper how fast this can go is friction. The friction with the the screw and the battery really is dependent on the magnet strength and the screw's weight. So if we can find that critical point, we have a couple different screws here to try this with. So this one's a little longer than that first one we tried with. If we can find that critical point where the screw's just about to fall off, that means our friction is just about zero, and we should get faster speeds. We'll play with this a little bit. I'm gonna just do the standard one. Okay. All right, so now we got the longer screw here. Tim's trying to get up to speed. Yeah,
and he burned himself.
It gets hot. So
Okay.
that current got a little hot for Tim. Current going through your body can be painful, as Tim just found out. What it's really doing is energy's conserved, right, Nancy? And it transferred to heat energy in Tim. It's still holding on there pretty well. So we're gonna try Tim's invention,
The double screw.
the double screw. It still holds.
Oh yeah.
Let's get it centered here.
Still holds pretty well.
All right. There we go.
That's seems a lot more steady. That weight's keeping it kind of centered more and should, well, if you got it in the center, produce less friction as well on that top connection between the battery and the screw. That's going pretty well. That's really, there we go.
Perfect. And it died.
Alright, so what we did here, we made a really simple motor, something Michael Faraday came up with over 150 years ago, and almost 200 now. It's coming up close. From everyday kind of materials, wire, battery, simple magnet, and some screws, and it goes pretty fast and it's pretty cool. We don't have anything else for you, do we?
No.
Nope.
No.
We are done.
So, hope you guys enjoyed that, and I encourage you to make your own. I think it's pretty cool. Get something so you don't burn yourself on that current, because you will if you hold the top of it. And yeah, happy physics.
All right.
Bye.